During the early formation of our solar system, 4 small rocky worlds assembled where the radiation of an infant sun was strong enough to push away light gases and destroy all ice. But with great enough distance, hydrogen, helium, and ices like water and methane were plentiful. In this region, 4 giants were born: Jupiter, Saturn, Uranus, and Neptune.
Through their gravity in the early history of our solar system, these gas giants have vacuumed up all of the available gas.
Humanity's curiosity extended to these distant worlds.
We'd explored the inner worlds of the solar system. We'd gone to Mercury, we'd been to Venus, we'd been to Mars. But the big worlds of Jupiter, Saturn, Uranus, Neptune, they really beckoned to the scientific community.
An expedition to the giants would require crossing a protoplanetary graveyard, a ring of asteroids, leftovers from the solar system's formation 160 million kilometers beyond Earth's orbit.
We had to traverse the boundary in between Mars and Jupiter, the asteroid belt. And we only had some basic telescopic observations of some of these objects out there. And was it going to be a region of space that we could travel through?
In 1972, NASA's Pioneer 10 became the first spacecraft to enter the asteroid belt.
The asteroid belt in our popular imaginings is a rubble-strewn region of space, mountainous-sized objects crashing together in slow motion. It's nothing like that.
Scientists estimated a 1 in 10 chance that the spacecraft would suffer a serious collision.
There's a lot of rock out there, but it is spread over an enormous ring or volume of space. Collisions do occur, but they are not as frequent as you might imagine.
7 months after entering, Pioneer emerged, triumphant.
Having a spacecraft like the Pioneers extend their reach out into the solar system was, again, another important stepping stone in our exploration of the universe.
By year's end, the probe completed a flyby of Jupiter, using the planet's gravity to escape the solar system. Pioneer 10 remained our most distant spacecraft until 1998.
A great deal that is most interesting in our solar system was beyond our reach until Pioneer 10 showed us the way.
In the 1960s, engineers at NASA's Jet Propulsion Laboratory noted an imminent alignment of the outer planets. A spacecraft would be able to harness the gravity of each and swing from one to the next using minimal amounts of fuel.
It was recognized that you could do a grand tour, the idea of rendezvousing with more than one planet.
But if NASA missed their chance, the alignment wouldn't reoccur for almost 2 centuries.
Voyager was an epoch-making moment in the annals of spaceflight.
Twin probes were crafted, Voyager 1 and Voyager 2. Together, they would provide unprecedented access to the outer reaches of our solar system.
It was going to be the first time that we had pictures of such incredible detail of those distant bodies.
Let's measure these things in great detail, but moreover, they're going to keep going. And let's build them for the long term. Let's see how long they can last.
1970s technology would have to endure the harsh environment of space for decades.
The Voyager spacecraft, by today's standards, are quite basic vehicles. They had old television cameras on board, not too different from what might have been used in a television studio. Their recording systems were 8-track tape.
Nevertheless, the equipment was capable of capturing essential details of the mission targets.
The modern ships that sail to the planets are unmanned. They are beautifully constructed, semi-intelligent robots.
Each Voyager probe also carried greetings from humanity.
The legendary scientist, astronomer and communicator Carl Sagan decided to send a cultural object along with the scientific missions on the 2 voyages, and this was the famous Golden Records.
I send greetings on behalf of the people of our planet into the universe, seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate. And it is with humility and hope that we take this step.
Nominally, it's a message for any alien species who happen to find them, but actually it's a message to us as humans that we have something a little bit special on our planet that we would like to send out into space.
If extraterrestrial life could decipher the instructions to play it, the record would reveal 115 images, 90 minutes of music, and greetings in 55 different languages.
3, 2, 1. We have ignition. And we have liftoff of the Titan Centaur, carrying the first of 2 Voyager spacecraft to extend man's senses farther into the solar system than ever before.
Voyager 2 was launched first on August 20th, 1977.
This is the most exciting mission that I've ever worked with. We're really going into the unknown. It's going to be one of the most scientifically productive of the planetary missions.
Voyager 1 followed 2 weeks later. In less than 2 years, each arrived at the first proverbial stop on their grand voyage. The largest of all the gas giants, Jupiter contains 2.5 times the mass of our solar system's other planets combined.
Jupiter formed from all these little globules of matter basically colliding together in the very early days of the solar system formation.
The infant world hungrily swallowed nearby asteroids and comets, bulking its mass even further.
Eventually, when it cooled down, it was able to accumulate gases. So now it has this sort of a solid core and then this huge amount of gas around it.
Jupiter is truly the king of the planets.
It's the dominant force in our solar system except for the Sun.
Pioneer 10 had captured our first close-up images of Jupiter, but the Voyagers would expose even more of the planet's secrets.
We knew there was something going on, and when Voyager got close, it saw a very complex place. It saw weather patterns more similar to here on Earth.
One of the key targets, Jupiter's Great Red Spot.
It's like a tropical cyclone, but huge. It was first observed almost 400 years ago, just to simply exist so long. It's fascinating, and it's still not completely well understood.
In the 19th century, the Great Red Spot stretched 3 Earths across. But when the Voyagers visited, it had decreased to 2.
The scale of Jupiter in particular, I think, is one of the more striking reminders of just how small we are when you look at features and realize the entire Earth can fit within, with space to spare. It really is the land of the giants.
While Jupiter's massive cyclone had been known for centuries, Voyager 1 revealed a completely new feature. Rings, like Saturn. So faint that no one had spotted them earlier, the rings were likely formed by Jupiter's moons shedding dust, which settled into their parent's orbit. future discoveries would reveal rings around every gas giant in our solar system.
Saturn turned from being the solitary jewel to actually being just one of a whole family of ring planets in our solar system.
The Voyagers also investigated some of Jupiter's natural satellites.
The moons of Jupiter, pivotal in human history because of Galileo's discovery of the 4 large moons of Jupiter, that it kind of turned our view of the solar system on its head.
Galileo's 1610 revelation helped disprove the geocentric model of the universe. Earth, the other planets, and their satellites all moved in orbit around the Sun. The innermost Galilean moon, Io, is a hellish world, home to as many as 400 volcanoes.
The volcanoes are spewing sulfur dioxide, and they're actually producing a ton of sulfur dioxide per second.
The Voyagers captured a surface covered in lava and sulfur, in part caused by the moon's close elliptical orbit around such a massive body.
Normally a moon wouldn't have such an active core, but it's actually being caused to have an active core by Jupiter itself.
The uneven gravitational tug of Jupiter drives rocky tides. Io's surface bulges in and out by as much as 100 meters each cycle, and the frictional forces keep its interior warm and subsurface rock liquid.
It is the most volcanically active body in the solar system because of the internal pressures and temperature that generates.
But it's the smallest of the Galilean moons, Europa, which holds the most interest. Scientists believe Europa has a subsurface ocean with more water than exists on Earth.
Europa has liquid oceans under its heavy ice shell.
We can see the effects of currents in that ocean, convective currents flowing to the surface and breaking up the ice. It's a circulating ocean.
And where there is water, there is the opportunity for life.
We're talking now about the potential of Europa being a living world.
We've got liquid water, we've got a strong energy source, and organic chemistry. On Earth, those same ingredients in less than 1 billion years gave rise to life.
Closer images of Jupiter and its moons would have to wait until the end of the 20th century. The Galileo spacecraft deployed from Shuttle Atlantis in 1989.
It's been a long time coming, but you have a go for deploy.
Galileo is on its way to another world. Fly safe.
But its journey to Jupiter would span 6 years. En route, Galileo witnessed an extraterrestrial collision. In 1994, the spacecraft watched as the comet Shoemaker-Levy 9 was torn apart by Jupiter's immense gravity.
Sometimes there's a lot of luck in space exploration. Celestial mechanics came together to give us one of the most spectacular events in our solar system.
Many thought that Jupiter's clouds would simply swallow the pieces up. However, as each fragment crashed into the atmosphere, they released more energy than Earth's entire nuclear arsenal.
Galileo was able to capture the distinct holes and the distinct impact craters, and that the biggest one was thousands and thousands of kilometers wide.
The collision of Shoemaker-Levy 9 demonstrated how Jupiter's gravitational presence affects our own world.
With Jupiter, we have this gravitational bully that has influenced our own history as much as that of all the other planets.
Jupiter, because of its gravity, pulls these things into it.
It is very likely that it has shielded us from asteroid and comet impacts,
which may help understand why life formed here.
Under the Galileo mission, 2 explorers ventured to Jupiter. A small probe accompanied the main spacecraft, bound for a brief but crucial encounter with the planet's atmosphere. Each arrived in December 1995. But while Galileo entered orbit, its probe dropped beneath Jupiter's cloud tops.
The Galileo probe was actually able to plunge down through that atmosphere and see if there was water.
The probe quickly hurtled to a final measured depth of 180 kilometers.
Did it rain from the clouds of Jupiter? What were the temperatures? What were the pressures like? Was there lightning in that atmosphere? And along the way, it discovered all of those things, proving the theories that we'd had about this dynamic world for the very first time.
After loss of signal, the probe was vaporized. In 2003, following its 35th orbit, a dying Galileo was steered into Jupiter's atmosphere, meeting the same fate. The craft had not been sterilized prior to launch. This act of destruction would ensure no life, had it survived the journey, could contaminate Jupiter's moons. For the next 13 years, we could only study Jupiter from afar.
Ignition and liftoff of the Atlas V with Juno on a trek to Jupiter, a planetary piece of the puzzle on the beginning of our solar system.
In 2016, the solar-powered Juno spacecraft arrived and settled into a polar orbit.
The purpose of the Juno spacecraft was not to show us the clouds of Jupiter once more, but to actually understand more about what's going on inside the planet. How do gas giant planets like Jupiter actually form in the first place? We don't know how big worlds like that actually get built.
On each of its highly elliptical orbits, Juno passed Jupiter with only 8,000 kilometers to spare.
This is akin to skimming around a basketball just 1 centimeter from the surface, but of course we're doing this at tens of thousands of kilometers per hour.
Juno allowed us to understand what hides beneath the clouds, down to the core itself.
We've got a wibbly-wobbly core in the interior of Jupiter, generating this enormous magnetic field.
A magnetic field that is some 20,000 times greater than the Earth. Juno was actually built with a significant shielding just to prevent its electronics being fried by these close approaches.
Inside Jupiter, it ceases to be a gas giant. The hydrogen becomes compressed into liquid, and it takes on metallic properties.
Juno has helped us understand that structure in incredible detail.
As we enter the 1980s, both voyagers approached their next target. The second largest planet in our system, named after the Roman god of agriculture, the ringed world Saturn. Saturn has been observed in the night sky since antiquity, and its rings revealed not long after the first telescopes were crafted.
When Galileo turned his telescope towards Saturn, he was really confused. No one in humanity knew that a planet could have rings around it. The best he could come up with trying to describe Saturn was that it looked like it had ears.
In 1659, Dutch astronomer Christiaan Huygens employed a more powerful telescope of his own design and deduced that Galileo's ears were actually a system of rings. Each Voyager spacecraft arrived at Saturn months apart.
The Voyagers revealed a huge amount about Saturn. They discovered rings that had not been detected from the Earth.
Rings 200,000 kilometers across, but only maybe 10 meters thick. an average overall.
They were able to resolve the rings into their component parts, little chunks of rock and ice.
Dust grains up to boulders as large as mountains, racing around the planet at 80,000 kilometres per hour, with its own strange magnetic field suspending dust particles above and below the rings.
In the last day, we have learned a great deal about Saturn and its surrounding rings and moons from the dramatic pictures that have been brought back by the Voyager 2 spacecraft.
With Voyager's new data on the rings, their puzzling origins became a little clearer.
The rings of Saturn have been a mystery for many years in terms of how they came to be there.
Had they formed with the planet itself, or did they materialize later, Saturn's immense gravity destroying a smaller, wayward body?
Perhaps it was a relatively recent event in which an ice moon got too close to the planet to stay intact and became broken up into rings.
Christian Huygens also discovered Saturn's largest moon, Titan, in 1655. Later that century, an Italian-French astronomer by the name of Jean-Dominique Cassini discovered 4 more. In 1997, NASA, ESA, and the Italian Space Agency launched their joint exploratory mission named after both men, Cassini-Huygens.
In many ways, the Cassini-Huygens mission grew out of the Voyager missions because what we saw in the vicinity of Saturn was utterly tantalizing.
The mission consisted of 2 separate spacecraft.
The Cassini probe, which is a NASA project, and the Huygens probe, which actually came from Europe. These 2 teams from different sides of the Atlantic could achieve so much more, I think, than either project would have done alone.
For me, a highlight in the exploration of the outer solar system has to be the Cassini-Huygens probes. We've learned so much about not only Saturn, the beautiful ringed planet, its atmosphere, its rings, but also its many, many moons, which are really fascinating.
An extraordinary mission. 13 years of absolutely marvelous discovery. Some of the things that were found were so surprising. They'd never been thought of when the spacecraft was being planned.
Cassini-Huygens arrived at Saturn after a 7-year journey. The first mission to orbit the planet, Cassini provided unprecedented detail of Saturn's rings by flying through them. Mission Control had to precisely navigate the craft through the debris. Tensions were high on every pass.
What will it encounter as it passes through that ring? What effects will there be on the electronics of the system? Are there particles or small objects with which the spacecraft will collide and be destroyed? That requires some very, very clever use of orbital mechanics.
We saw evidence for essentially water falling out of the rings, something like 40 tons per second. The rings themselves are actually raining onto the planet's surface.
Cassini was able to observe the first hurricane-like structure on Saturn, the Great White Spot, and watch a hexagonal atmospheric structure at Saturn's North Pole change from blue to gold.
The hexagonal feature that's at the North Pole of Saturn is due to a massive hurricane, and it's about 50 times more massive than any hurricanes we get on Earth.
Again, there are weather systems like on Earth that there are on these gas giants, something we never would have thought of.
On July 19th, 2013, the Cassini spacecraft imaged Saturn and its entire ring system during an eclipse of the sun.
One of the most spectacular images it returned was actually from the far side of the planet, looking back towards Saturn with the sun lighting it up from behind.
Spanning over 650,000 kilometers, The picture details Saturn's second outermost ring, composed of fine icy particles. The photograph also features a pinprick of light, the Earth, 1.4 billion kilometers away.
NASA knew that the Earth was going to be in that shot and decided to say to everybody, on that day, at that moment, go outside and look towards the skies, because your photons will be emanating from the surface of the Earth and received by the Cassini spacecraft.
During its mission, Cassini snapped images of many Saturnian moons, but one held the spacecraft's focus. Enceladus is Saturn's sixth largest moon. Its distinctive southern stripes sit atop a saltwater ocean, buried kilometers below its icy surface.
Close inspection by the Cassini spacecraft showed cracks in that ice and showed water geysers spraying out from a subsurface ocean.
These eruptions fling material into space, and it means that you don't have to land on this moon to access this ocean. You just wait for a geyser to erupt.
And Cassini was flown through those geysers and was able to taste those waters and found that the water was warmer than we expected it to be. And it was full of both simple and complex organic chemistry. It suggested that there could be thermal vents at the bottom of an ocean where life could thrive.
If I had to bet on a best candidate for life in our solar system, I think I would pick Enceladus. If we can actually go to Enceladus in the future and send drones under the water and see what's down there, I think that will be an absolute watershed for our understanding of whether life could potentially exist in our solar system.
Maybe life really is common out there, or the conditions for life are common out there. And if this little cold place around Saturn has it, it's probably common.
Decades before Cassini, Voyager 1's brief encounter with Saturn's largest moon, Titan, whetted our appetite.
Without a question, the images that were returned this morning revealed a world unlike any of the others that we've seen.
It was tantalizing. It told us things that we hadn't known before, but left so many questions unanswered that we just had to go back.
The secrets of Titan were buried beneath its thick, hazy atmosphere.
It's opaque for the same reasons that we get this haze of smog in some of the more populated areas of the world. Titan's atmosphere is rich in hydrocarbons, mostly ethane and methane. And the effect of the sun's radiation on those hydrocarbons is to turn it into a very hazy atmosphere.
After deploying from Cassini on December 25, 2004, Huygens began a 22-day journey toward its target. Upon arrival, Huygens descended for 2.5 hours.
The European Space Agency sent a landing mission to Titan as part of the Cassini mission. It successfully soft-landed on the surface and sent back a whole bunch of data.
The first craft to land on an outer solar system body, Huygens continued to transmit data for 72 minutes until its batteries were drained.
And it revealed to us a world that has ice mountains and sand dunes and river-like features, not from liquid water flowing from the surface, but from organic molecules of ethane and methane raining from its clouds, flowing across a water ice surface and flowing into vast lakes.
It was almost primordial. It was kind of like a snapshot of what we thought Earth was like 3 billion years ago when life was just starting to come into play. And if life formed on Earth in very similar conditions, maybe it's forming or has formed on Titan.
This is not life as we know it, but it's conceivable that something could be there. The chemistry is complex enough that life may form. Could we recognize it if it did, is perhaps another question.
After 20 years in space and 294 orbits of Saturn, Cassini was running out of fuel. The mission embarked on yet another risky first, a journey between Saturn's atmosphere and its rings.
The choice was to send Cassini through Saturn's rings, through a very small gap actually, and to do this multiple times to learn more about what was there.
Diving through Saturn's rings 22 times, Cassini sought to determine their age. In 2019, astronomers revealed the answer, somewhere between 10 million and 100 million years old, a fraction of the age of the 4.5 billion-year-old planet they encircle.
And then eventually the final swan song was to send it into Saturn itself for a very scientific ending where it was transmitting important data right until the last second.
Signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. I'm going to call this the end of mission. Project manager off the net.
Four decades before Cassini's demise, Voyager 1's mission to Titan ensured a lonely outward path, a journey that sent it straight out of the solar system. Voyager 2 carried the responsibility of visiting the remaining planets, the ice giants Uranus and Neptune. Sir William Herschel first observed Uranus on March 13th, 1781, though he did not initially identify it as a new planet. After all, it was the first that had not been known to the ancients. Just over 2 centuries later, Voyager 2 approached within 82,000 kilometers of Uranus's cloud tops.
Uranus is an oddity that Voyager's eyes were able to show us really a lot of interesting features of very high jet streams racing through its polar regions and equatorial zones, and to show a little bit more detail than we can get from here on Earth.
Voyager 2 studied Uranus's unique atmosphere, manipulated by the planet's strange orientation. Uranus lies on its side, with a tilt approaching 98 degrees. It's thought that an Earth-sized object may have collided with Uranus long ago, pushing the planet over. Its atmosphere reaches the lowest temperatures of any planet in our solar system, plunging as low as minus 224 degrees Celsius.
The ice giants are so far away from the sun that they're receiving a really tiny amount of the sun's light, between 100th to 1,000th of the sun's light.
Uranus's distinct coloring comes from the presence of methane in its atmosphere, which exists in greater concentrations than in its larger siblings. But like all the giants, Uranus has its own system of rings. The brightest of the Uranian rings had been discovered a decade prior aboard the Kuiper Airborne Observatory, an airliner fitted with an infrared telescope. Voyager's observations brought the total to 11. Voyager 2 also provided up-close images of the moon Miranda, one of the strangest bodies yet observed in the solar system.
When that first of the series of Miranda images came in, just where it was supposed to, it was that sense of, oh my God, we did it.
It looks like a world that has been smashed up, torn apart, and then put together again really, really poorly.
One half of it is deep curved furrows on its side, and the other half of it is an average-looking pockmarked moon that you would see in orbit around another planet. And there they are, together. They're completely different, but they're in the one body.
Cliffs that are over 20 kilometres high, and the gravity of Miranda is so low You could stand at the top of that 20-kilometre high cliff, look straight down, jump off the edge of that cliff, take 20 minutes to reach the bottom. You'd be able to land on your feet and walk away.
In August 1989, Voyager 2 approached the final target of its grand voyage, Neptune, which was first revealed not with a telescope, but with mathematics.
The planet Neptune was discovered by its gravitational pull on the planet Uranus. So before we even saw it from the light that it emits, we inferred that it would probably exist because the orbit of the other planets were kind of being pulled out of line.
To speak with Voyager 2 at so great a distance would require a new technical achievement.
Probes like the Voyagers, they're very quiet. The further you go, the bigger and bigger we need to make our receiver dishes to pick that up.
In 1986, NASA established its Deep Space Network, 3 communication complexes around the world that improved our ability to capture the weak radio signals from Neptune.
Our job is to send commands to spacecraft so they know where to go, what to do, and what information to collect.
Each complex of the Deep Space Network has a 120-degree field of view. To achieve full coverage, NASA built the first station in California's Mojave Desert, the second station in Madrid, and a third near Canberra in Australia. Once a mission travels more than 30,000 kilometers from Earth, it is always in view of at least one of the stations.
I describe it as being air traffic control for the solar system or the postal service for the universe.
In 1987, the 3 main telescopes were expanded to better hear Voyager 2's Neptune encounter. When it arrived 2 years later, Voyager revealed at least 4 rings of ice and rock. It also discovered the Great Dark Spot on the planet's southern hemisphere, a raging transient hurricane the size of the Earth. The winds on Neptune can reach speeds of over 2,000 kilometers an hour, the fastest in the solar system. En route, engineers altered Voyager 2's trajectory so it could study the largest of Neptune's moons, Triton.
A world with a thin atmosphere, with geysers spraying out dark sooty material, not water ice as we'd experienced at some of the inner moons of the other giant planets, but dark material that thin atmosphere and winds were carrying across the surface, creating dark streaks on the surface of the moon.
Days later, it snapped a final photo. Neither Uranus or Neptune have been visited since.
The ice giants Uranus and Neptune were all but points of light to astronomers until the flyby mission of Voyager 2.
We started to realize Uranus and Neptune are very different than Jupiter and very different than Saturn. We kind of had this view pre these missions that the 4 gas giants were all the same.
We saw worlds that had some of the coldest temperatures ever recorded, with some of the fastest winds ever moving, where the energy for such dynamic systems is still a bit uncertain.
We've been sending deep space probes out for decades now, but there's these 2 planets that we know only from the visit of Voyager 2.
We really know very little about these planets, and it's very much overdue, I think, that we send back another probe and have another look.
We might have a reason to go back, but we have so many places to explore beyond Earth and our solar system. Where do we go? There's just too much to do.
Beyond our outermost planet lies a mysterious realm of small rocky worlds that the Voyagers would merely pass through. But they were not forgotten. 4.5 billion kilometers beyond our Earth lies a realm of icy bodies, the remnants of our solar system's formation.
The Kuiper Belt is a huge region at the edge of our solar system where the comets live. So it's a very, very mysterious region.
Despite its massive size, the Kuiper Belt wasn't discovered until 1992. Within it lies a world once called a planet, Pluto. Discovered by 24-year-old Clyde Tombaugh in 1930, Pluto was reclassified as a dwarf planet in 2006, following the discovery of several other objects in the Kuiper Belt that were similar in size. However, that has not detracted from our desire to unlock its secrets. The New Horizons probe was developed to expand Voyager's grand tour of our solar system.
The New Horizons spacecraft was able to go where the Voyagers couldn't go. They couldn't encounter that final traditional world of our solar system, Pluto.
The probe embarked from Cape Canaveral on January 19, 2006.
There were so many unknowns about Pluto, how it was formed, what it would look like.
At a distance of nearly 5 billion kilometers, it would take over 4 hours to send and receive radio signals from the probe. The download speed from New Horizons was only 1 kilobit per second, 50 times slower than the dial-up modems of the 1990s. It took 15 months for all of the information it gathered to return to Earth.
Everybody was waking up in the morning, ready to download all the latest images that had come in and been processed and were all being put up online.
It's just amazing what this meant to all the people that worked on it, but it also meant a lot to people around the world.
Until New Horizons, scientists weren't even sure of the dwarf planet's actual size. They were able to conclude that Pluto is 2,376 kilometers in diameter, the largest of the catalogued dwarf planets. But it was the features on its surface that were truly astounding.
A world with nitrogen ice glaciers flowing across its surface into valleys underneath mountains that were 3 kilometers high, made from water ice, covered in a nitrogen snow.
The textures and the patterns make it look a bit like an artwork in places.
And surprised us by revealing an extraordinary heart-shaped region of very smooth landscape. It's a new surface, and by new I mean within perhaps 1 million years. Certainly not the ancient cratered surface that everybody expected to see.
As New Horizons departed Pluto, it revealed a naturally blue sky, created by nitrogen gas, just like on Earth.
The sun shining behind Pluto, lighting up that blue atmosphere and the blackness of deep space that we're traveling out into, leaving behind the worlds of our solar system to head into the interstellar void.
Observations of the outer solar system continue to raise as many questions as answers. Indeed, a number of objects beyond Pluto follow unusual orbits. Orbits that could hint at an unseen gravitational force. Another planet, currently dubbed Planet 9.
If we look at the other objects in the very outer solar system, some of the asteroids, the rocks that are floating out there, they seem to be pulled a little bit off target.
These orbits all seem to line up pretty well in one direction, and that tends not to happen by chance.
There could possibly be a very massive planet out there that we haven't yet discovered, Planet 9.
For it to be there, and for it to be having the effect that it is, it has to be pretty big.
Somewhere between Earth and Neptune, what we call a super Earth. which is interesting because super-Earths are very common around planets around other stars. So one of the most common types of planets in all the other star systems just happens to be the one we're missing.
Mathematical modeling and computer simulations hint at Planet 9's existence, but it has yet to be observed directly.
Now, Neptune-sized objects would be quite big, and you might expect that we would see that pretty easily, except that this could be 20 times as far away as Neptune is.
The light that we see from the planets is reflected from the sun. And if there is a ninth planet, it would be so far away from the sun that the light would be incredibly faint.
The problem is that the most likely direction that we think this thing might be in, this hypothetical Planet 9, is actually slap bang in the middle of the Milky Way, the most dense part of the sky as far as how many stars there are.
How do you separate what could be a planet, a dim reflecting object in the night sky, from the many other background stars? Well, it moves relative to these background stars, which to our telescopes essentially appear fixed.
As it would take Planet 9 between 10,000 and 20,000 years to orbit the Sun, it could remain a distant mystery for years to come.
We're looking for a needle in a haystack, but the needle looks like hay. That's why Planet 9 hasn't been found yet, if it is there.
The Voyagers are now the furthest objects forged by humanity. And as such, they've given us the most distant photograph of our home.
On February 14th, 1990, it took a final image, turning its cameras back to the inner solar system and taking a panorama, a family portrait, if you will, of the entire solar system. And within one of the beams of sunlight, a tiny pale blue dot, the Earth, seen from the perspective of deep space.
I think it made everyone stop and wonder a little bit just about how large the universe is and our place in it.
In some ways, Voyagers 1 and 2 have both already entered interstellar space.
There are a few ways to define the edge of the solar system. One is to say, where does the influence of the sun end? And that would be called the heliosphere.
Both Voyagers have passed that last remnant of our own solar system and continue into our larger galaxy.
They have fuel that will probably mean that they can send signals back until maybe the mid-2030s. It's quite amazing that something launched back in the 70s could still be talking to us so far into the future.
The Voyager probes carry with them a history of humanity as spacefaring explorers and the promise of future discoveries.
It's the serendipitous discoveries as you go further and further into unknown territory, which we look back on and say, huh, didn't expect to see that.
The depths of space called, and humanity answered.
The Voyager spacecraft fundamentally changed our idea of what the outer solar system was like and showed us new worlds that beckoned to be explored.
And we have liftoff.
Our missions to the outer solar system have provided nearly half a century of milestones.
You really felt part of it. Every decade of your life, you saw something new about our own solar system. It was completely inspirational.
Each robotic surveyor has opened up the possibilities of future missions.
If we can actually go to Enceladus in the future, I think that will be an absolute watershed for our understanding of whether life could potentially exist in our solar system.
These distant travelers are a monument to human exploration.
It makes all of the solar system and beyond a human place, because that's how far we've gone.
As the Second World War came to a close, the United States and Soviet Union rushed to salvage Germany's scientific minds and the technology they had developed.
The space race really began, I guess you could say, out of World War II and the development of the V-2 rockets.
The world's first long-range guided ballistic missile, Germany's V-2, could cross the threshold of space.
Everybody knows there's this missile that can travel between continents, and it's been very successfully deployed in the UK and in Europe. And everyone knows there's a whole bunch of people with expertise.
US forces secretly evacuated thousands of German scientists and technicians out of Europe, far from the grasp of their communist former ally. The campaign was codenamed Operation Paperclip. A Cold War between the two ideologically opposed nations mounted. Each stockpiled weapons and the technical capability to deliver them. From America's perspective, the Soviets were too technologically backwards to develop a rocket capable of delivering a nuclear weapon to the United States. In 1957, the Soviet Union announced the world's first intercontinental ballistic missile, capable of carrying a nuclear payload 8,000 kilometers, the R-7. However, its enormous size proved impractical for warfare. The Soviet leader allowed his scientists to modify the missile to carry a satellite. Within weeks of the R-7's first successful test, the Soviets ushered in the space age. Bearing the Russian word for traveler, Sputnik climbed over 900 kilometers to the heavens.
The world was in anticipation that an artificial satellite would be launched, but everybody thought it would have the American flag on it.
A polished aluminium sphere measuring 58 centimeters in width, Sputnik's sole scientific instrument was a radio transmitter.
You are hearing the actual signals transmitted by the Earth-circling satellite, one of the great scientific feats of the age.
Sputnik transmitted a continuing series of beeps, which could be picked up by any person with the necessary equipment. Proof that the Soviet achievement was not fictional propaganda.
All over the world, people are tuning into the bleep, bleep of the satellite, which carries aboard the highly complicated mechanism necessary to transmit secrets of the universe.
It's a very characteristic beep, and I would love to know how much forethought went into that. For some, I'm sure it sounds inspiring. For others, it sounds kind of intimidating.
But to hear this artificial thing beeping and saying it above, I think put a real panic into some people.
And there was almost sort of hysteria, but at the same time, there was a fascination that humanity in some way had put this small object into orbit around the Earth, and thousands of people would go out each night to watch this tiny point of light travel across the sky.
It really triggered a huge interest in space that hadn't been appreciated in the wider population.
The space race was essentially here. It was not a pipe dream, it was reality.
The starting gun had been fired, and America was already behind. They quickly scrambled to place their first satellite into Earth's orbit.
In the universe, we know there is this thing called gravity. If you have something that's very massive, there's going to be a gravitational force pulling you towards that.
In the late 1600s, Isaac Newton conceptualized orbit using stones thrown from a mountaintop. The faster a stone is projected, the farther it will travel, before gravity drags it to the ground. But because the Earth's surface is curved, a stone projected with sufficient force would be pulled toward the Earth at the same rate the ground below is receding. Trapped in perpetual freefall, the stone would be in orbit. The United States Navy attempted to launch America's first satellite into orbit just 2 months after Sputnik.
Disaster follows, as this official film shows only too clearly.
Following Vanguard's failure, America's goal of space was handed to the Army. Wernher von Braun, the V-2 engineer snatched up during Operation Paperclip, would refine his Jupiter-C rocket to deliver the satellite.
We've been assigned the mission of launching a scientific Earth satellite. And we will use the Jupiter-C configuration as a carrier that we developed along with the Jet Propulsion Laboratory. I promised the Secretary of the Army that we would be ready in 90 days or less. Let's go, Werner.
They had to get something up there fast to show that they were still a major superpower when it came to space exploration.
Collaborating with the teams of William Pickering at the Jet Propulsion Laboratory and James Van Allen, the lead designer of Explorer 1's instruments, von Braun was ready in just 84 days.
2, 1, firing command, firing command.
Explorer 1 took a weapon of war, essentially an intercontinental ballistic missile, something to lob nukes at your enemy. And this converted rocket launched a satellite for scientific discovery.
They wanted to go up there, probably still use the propaganda, but also to use it for science, to really show the world that they were doing it for peaceful purposes.
Among its scientific instruments, Explorer 1 carried a Geiger counter. It confirmed the presence of a large band filled with high-energy charged particles, radiation that had been captured by Earth's magnetic field. Named for James Van Allen, the radiation belts sit high above the atmosphere, shielding Earth from the harmful solar winds.
There are experiments going on right now around the sun to better understand how these radiation belts affect us, because that directly influenced how the future missions were designed to send people past these belts onward to the moon.
On March 31st, 1970, Explorer's journey came to an end after 58,000 orbits. The next goal for both the Americans and the Soviets was to deliver a human to the stars and return them safely.
No one knew what the vacuum of space, the fact that there was no air and therefore no pressure, was going to do. No one understood the temperature ranges. No one understood, could a human survive?
Would a human being's blood not just pool up as little balls in their veins, or would they be unable to swallow? We simply did not know.
Forming in 1958, NASA initiated its human spaceflight program, Project Mercury.
The Mercury astronauts were selected from a very large number of flyers and ex-fighter pilots.
From all of the active duty pilots in the Navy, Marines, and Air Force, the service records of 473 test pilots were selected for review. 110 met the basic qualifications.
You could not just select the average human to go up. You needed someone who has a history of not only the physical effects, but what happens when something goes wrong.
They wanted people that had the right stuff. And out of the thousands of people applied who were tested, went through medical tests and psychological tests, it eventually came down to 7 men.
NASA revealed the Mercury 7 on April 9th, 1959. Following America's announcement, the Soviet Academy of Sciences selected 20 cosmonauts among their Air Force pilots. 6 received accelerated training, and 1 was chosen to be the first man in space, Yuri Gagarin.
Yuri is many things: a brilliant mind, a loyal Soviet. You could not have asked for a more perfect representation of your nation, because he is about to become the most famous man in history.
Gagarin's Vostok 1 was to take off from the same cosmodrome in Kazakhstan that launched Sputnik.
Some rockets accelerate extremely fast, and if you used those for a human, they wouldn't survive the launch. They couldn't take the G-loads. So rockets for humans have to take off relatively slowly, gradually pick up speed.
Within 10 minutes, Yuri Gagarin became the first human to cross the Kármán line, the border between the Earth's atmosphere and outer space.
Yuri Gagarin's flight, Vostok 1, was just incredible. He had a very, very risky mission, but the craft kept him safe and kept him alive, and that was a real technological feat.
The Vostok operated on autopilot, allowing Gagarin to perform tests on the life support and radio.
I think the thing that inspires me most about Gagarin's mission is when he finally got into Earth orbit and he saw the Earth for the very first time, and he spoke back to Mission Control saying, "I see the Earth. It's so beautiful."
The Vostok's single orbit lasted only 108 minutes. However, placing Gagarin in space was only half the challenge. Bringing him home would be just as perilous.
If you're in your capsule returning to Earth, you're going to be careening down through the Earth's atmosphere. And at the speeds we're talking, it's going to generate an enormous amount of heat.
The gas that's right at the nose of the re-entry module can be hotter than the sun.
The re-entry capsule failed to separate from the service module, sending both into a life-threatening spin. Luckily, the friction burned through the cables connecting the two. 2.5 kilometers from the ground, Gagarin ejected. Had he landed inside the Vostok, the force of the impact would have ended his life. Yuri Gagarin's safe return penned a new chapter for the world.
This Russian achievement of landing an astronaut safely after orbiting the Earth is really one of the greatest events in the history of mankind. The Russians have succeeded in breaking the barrier which binds man to Earth, and the path is now open for them to explore the solar system.
It was an extraordinary act of bravery that Yuri Gagarin undertook. We knew that humans could go into space and not only live, but survive and possibly even thrive.
A month behind Gagarin's orbit, NASA sent their first man to the stars, aboard Freedom 7.
Alan Shepard was the first US astronaut to achieve insertion into space. He was certainly in outer space, but it wasn't really an orbital ride.
There was no intention for Freedom 7 to complete a full orbit.
All right, lift off and the clock is started.
Reaching an altitude of 187 kilometers, Shepard traveled 486 kilometers from the launch site, splashing down in the North Atlantic Ocean. The entire flight was over in under 16 minutes as planned. America wouldn't attempt their first Earth orbit until 1962. John Glenn's Mercury capsule bore the name Friendship.
All stations, gantry is in launch position. Start interrogation in 1 minute. Godspeed, John Glenn. Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous.
John Glenn successfully traversed the globe 3 times.
This is Mercury Control. The Friendship 7 spacecraft is now committed to its 3rd orbit.
Unlike Gagarin's journey, which was shrouded in secrecy, the flights of Shepard and Glenn were broadcast around the globe.
Never in all of history have so many people shared, without censorship, an adventure of such magnitude. Through all news media in all languages, all the peoples of the world are witness to this exploration of space.
Across 3 years, both the United States and Soviet Union completed 6 solo missions, but America still lagged behind. The Mercury astronauts spent less than 54 total hours in space. The Vostok cosmonauts totaled 16 days. The Soviets achieved the next first with the flight of Vostok 6 in 1961.
Vostok 6 was historic. It saw the first female cosmonaut, Valentina Tereshkova.
Tereshkova spent nearly 3 days in orbit. However, the nature of space sickness wasn't fully understood at the time. Ground control was unsympathetic to her condition.
The stories that came back later was that she was groggy, didn't respond quickly to commands, and while she was very much celebrated as being the first woman in space, she was also heavily criticized.
Despite the complications, Tereshkova paved an important stone on humanity's path to the stars. With a dozen single-occupant missions in the history books, the space race competitors strove to increase the size of their crews.
One person can only do so much, and you're going to need support from other people, whether that's for health reasons or different skill sets.
NASA approved the Gemini program 3 months before John Glenn's orbital flight. It would take years to develop a capsule for 2.
It's not a linear problem. It's not as easy as simply taking a small spacecraft and scaling it up. The complexities of the aerodynamics becomes quite challenging in achieving the right design for stability and for protection against the thermal conditions.
To ensure they remained ahead of the US, the Soviets retrofitted their 1-seat Vostok capsule and placed an extra rocket on the exterior to create the Voskhod.
The need to put more crew meant every single piece of weight had to be justified, to the extent that the crews themselves were even going on diets.
The life-saving ejection seat was stripped, and the Voskhod 1's crew would venture into space without protective suits.
No second chances, no backup. If the pressure of air for breathing was lost, then that would have been it.
Voskhod 1 set a crewed spacecraft altitude record of 336 kilometers. The crew returned safely, but the mission initiated a trend toward unacceptable risks in the Soviet space program.
This is what the space race was about. It wasn't about some high-minded desire to understand the solar system and the universe. It was literally about getting something done before the other nation. And if that meant cramming more people into a sardine can, then that's what you did.
While the Americans prepared for their first 2-man team in space aboard Gemini 3, the Soviets sprinted ahead. Crewed by Pavel Belyayev and Alexei Leonov, the second Voskhod mission hoped to achieve the first spacewalk. Voskhod 2 was equipped with an inflatable airlock, facilitating Alexei Leonov's transition into space. Once cosmonaut Leonov exited the craft, he beheld humanity's first unencumbered view of the world.
You're in a capsule. You have very limited amount of material between you and the absolute guaranteed death of space. The thought of then leaving that and trusting to essentially fabric is appalling.
A 5-meter tether was all that kept him from floating into the void.
Alexei Leonov was from the military, so I'm sure he would have been very disciplined about what he was doing.
Leonov later wrote that he felt like a seagull with its wings outstretched, soaring high above the Earth.
He was the first person with an almost perfect view of our planet hanging there.
Taking in this amazing view beneath him, the Earth, our home, the fragile atmosphere that we have, and him linked to a spacecraft by just a tether.
However, Leonov's historic spacewalk quickly turned into a disaster. He noticed that his hands were slipping from their gloves and his boots no longer fit. His suit was expanding in the pressureless vacuum of space. Leonov had only minutes to re-enter the Voskhod before he would be plunged into darkness as the craft entered the Earth's shadow. The cosmonaut vented half his suit's oxygen as a last-ditch effort to reduce volume and regain mobility.
It was a quick decision in the matter of literally minutes. He didn't know if that was the right or wrong answer. He just knew that was his only chance of survival.
The hatch was finally closed. But the explosive bolts that separated the airlock sent the capsule into a spin. The Voskhod would touch down 2,000 kilometers beyond their emergency landing site. When rescue teams finally discovered the crew, they had spent 2 nights in a Siberian forest, enduring temperatures below -25 degrees Celsius.
So the Russians were willing to take more risk up front because they were going to get longer-term reward. That was the only way they were going to establish dominance over the US.
There would be no further Voskhod missions, hinting at an end to Soviet space supremacy. Humanity's foothold in space, however, was not free of tragedy. Both the Americans and Soviets lost lives. In January 1967, 3 NASA astronauts perished when fire erupted inside the Apollo 1 capsule during a ground test. Two months later, cosmonaut Vladimir Komarov, the commander of the Voskhod 1 mission, became the first of the space race to die whilst in flight. Returning to Earth, the parachutes of his Soyuz 1 capsule failed to open. Soviet lunar dreams were suspended for 18 months, during which time Yuri Gagarin, the first man in space, died in a jet crash.
I'm going to step off the limb now.
The following year, America reached the moon.
It's one small step for man, one giant leap for mankind.
Having lost the lunar race, the Soviets shifted their focus toward establishing a semi-permanent presence in orbit. In June 1971, Salyut 1, the premier space station, received its first crew via the Soyuz 11.
There were 7 Soviet space stations that they launched periodically from 1971. They really pioneered another first for the USSR. They really pioneered how to live in space.
If you want to really learn the fundamentals in physical processes, then you're going to have to do an experiment without the gravity. And places like the numerous space stations that have been in orbit give you a convenient laboratory to do that.
In 1973, the United States launched its first space station, Skylab.
Skylab was essentially the answer to the question, what do you do with the Saturn V when you no longer can afford to go to the moon? Do you use its spare parts to build a space station?
But as soon as the uninhabited station was placed in orbit, it required repairs.
After the launch of the Saturn 1B rocket, the solar panel, one of two, actually ripped off, and its sunshade, which was to protect the spacecraft from the radiation of the sun while it was in orbit, was also damaged.
The first team deployed to Skylab were tasked with restoring the station.
So the astronauts had to have an emergency repair mission. And that itself was a difficult maneuver. The two astronauts outside in a ballet of trying to actually hold one astronaut by the legs while the other was using a long pole with some scissors on the end to cut that cable.
Rotate the pole clockwise on that. Okay, that's pretty good.
Eventually, of course, just the ingenuity, the efforts of human beings being up there managed to get the station up and running.
The main operational section, where crews would work and live, was crafted from a refitted Saturn rocket. It had a galley, a zero-gravity shower, and sleeping quarters.
We have 3 bedrooms that we can live in. They're very small. The beds are on the wall as opposed to on the floor, but they're still ample in zero-G.
Every aspect of life had to be navigated in the novel environment of microgravity.
Because there's that lack of gravity, you get fluids that pool in the outer extremities of the human body, in the face and the hands and the feet. The heart muscle is decreasing in size. It doesn't need to work against gravity to get blood from your feet to your head. You get changes to the shape of the eye, which can change your focus. You also get the effects of decalcification in the bones. Your bones don't need to hold you up while you're in space.
Astronauts exercise for several hours a day just to keep their bodies fit and their physiology ticking over. So human beings aren't designed for microgravity, that's for sure.
Skylab remained in orbit for less than a year, while the 3 teams completed 270 different experiments.
The key experiment that was being undertaken was actually on the astronauts themselves. Can humans remain healthy? Can they remain sane in space?
The third and final crew of the station was so exhausted, they shut off communications with mission control for a full orbit.
The commonly accepted story is that the 3 Skylab astronauts had just felt they were overworked, so they turned off the comms and they said, "We're out for the day. We're not doing anything, we're not talking to you."
The 93 minutes of radio silence sparked negotiations. The 3 astronauts received a more lenient schedule and ended up completing all their tasks on their own time. NASA learned a valuable lesson. Their crews had limits. In January 1967, the United States and Soviet Union joined with the United Kingdom to sign an international agreement regarding future space ventures.
The Outer Space Treaty of 1967 was designed to prevent the proliferation of nuclear weapons into orbit and beyond. It was to try to limit the claim staking of governments. In other words, the exploration and utilization of the celestial bodies, the moon and beyond, should be for the peaceful purposes of mankind, for the benefit of all, for exploration.
While the governments of the USSR and US remained engaged in a stalemate backed by mutually assured destruction. attempt to de-escalate tensions produced the first united American-Soviet space mission. The Apollo-Soyuz test project would see the two separate spacecraft unite in orbit.
The Apollos and Soyuz scientists are sharing information, so you have to unclassify and share all of your deepest, darkest secrets with the other people in order to make this work. That's the beauty of it, is that they were willing to think beyond the borders of their countries and their philosophical differences to think of a bigger picture, a bigger purpose, which is ultimately the benefit of space exploration in the midst of terrible, terrible times.
Well, I recognize that almost any subject there are differences of opinion. My feeling is that people who understand this mission understand that it is a very fine thing to do for both countries and for the entire world. I think this is a first movement in a direction of joint operations in space in the future.
Both countries launched 7 hours apart.
3, 2, engine sequence start. 1, 0, launch commit. We have a liftoff. All engines building up thrust.
Both control centers, Moscow and Houston, have given a go for docking.
Part of the Apollo-Soyuz mission was essentially to get the command and lunar modules from the Apollo missions and to add a sort of docking platform so that then the Soyuz capsule could dock with those existing platforms.
I got 2 messages for you. Moscow is go for docking. Houston is go for docking. It's up to you guys. Have fun.
How do we dock these two together and what does that look like? What's the interface? Who wants to be the plug and who wants to be the socket? Is there going to be an argument there? I think so, there was. And so they had to completely redesign their approach just to how you attach two things together. They ended up calling it the androgynous peripheral attach system, and it's still used to this day, actually, to dock two things together.
Less than 5 meters distance. 3 meters. Contact. Capture. Tell Professor Bushulian it was a soft docking.
When the hatch opened, Apollo 10's Thomas Stafford and Alexei Leonov joined hands in the first international handshake in space.
Glad to see you.
The moment when the two commanders actually greeted each other seemed to be heralding a new era.
It really signaled the end of the space race and a new era of international collaboration between nations that had previously kept their programs very secretive.
Over 44 hours, the two teams exchanged gifts, dined together, and conducted joint experiments. After undocking, Apollo eclipsed our Sun, so the crew of Soyuz could study its corona.
The fact that these two former arch rivals in the world of space could come together, it seemed like a pivotal moment in perhaps human cooperation as well as activities in space.
Following the success of their Salyut stations, Soviet plans for space habitation grew more ambitious.
There never will be launch capabilities sufficiently large and powerful to lift an entire space station into orbit.
And so the only way you can get something of significant size up into orbit is to put a bit up there and then slowly add to it.
After the first section of Mir was launched in 1986, 6 pressurized modules were added over the decade.
One of the things that interests me about Mir is that cosmonauts on board the spacecraft actually straddled the end of the Soviet Union, the end of that era.
Sergei Krikalev was on his second tour aboard Mir when the Soviet Union fell.
He was a stateless person in orbit around the Earth, not quite knowing where he belonged.
Serving as the flight engineer, Krikalev agreed to stay and perform the same duties for the next crew.
Flying to Mir as a Soviet citizen and returning to Earth as a Russian citizen.
Falling around the Earth at an average height of 360 kilometers, the name Mir translates to peace.
It was really filled with international projects, and many other nations were invited to take part.
Mir was visited by astronauts from a variety of nations across North America, Europe, and the Middle East, as well as a television reporter from Japan.
And it's wonderful to see a project that was truly international in spirit, going up into space and creating that environment that later led to the wonderful international cooperation that we see today.
However, towards the end of its life, Mir was plagued with hygiene issues.
I think Mir was a little bit like a cruise liner, can be a little bit susceptible to people's infections.
Mir was surrounded by a cloud of little yellow frozen urine drops. Waste management, always a big issue when you're in space.
Urine particles even damaged the station's solar panels.
By the end of the program, in fact, it had to be abandoned, unfortunately. But it was a pretty successful experiment all up. There was a lot of scientific achievements.
By the late 1990s, malfunctions and hazards were mounting. Mold growth, computer crashes, even a fire. The station was abandoned in 2001, left to burn up as its orbit naturally decayed. The same year humans set foot upon the moon, NASA hatched plans to reinvent space transportation.
The shuttle encapsulated the science fiction that I'd read as a kid. A vehicle that would go into space and would land like an aircraft.
It's called a reusable space shuttle, an airplane-like spacecraft that can be hurled aloft by a rocket up to 100 times.
It is actually an aviation system. It generates some lift with its wings and with the underside of its fuselage.
And it just made the concept of going to space so much more accessible.
The challenge there is literally in the reusability. What's going to go wrong over time in doing this immensely difficult thing, technically speaking, again and again, and to be confident that the next time you did do it, everything would still be fine.
Space Shuttle Columbia was ready for the program's maiden orbital flight on the 20th anniversary of Gagarin's journey to space. All subsequent launches would follow the same routine. 2 solid-fuel rocket boosters flanked the shuttle for the first 2 minutes of launch. They would later detach to be collected for subsequent flights. A disposable external tank filled with liquid hydrogen and oxygen powered the shuttle to space. It would burn up during re-entry. In order to withstand multiple journeys through the Earth's atmosphere, NASA engineered a resilient thermal shield. The shuttle's aluminium shell was encased in over 24,000 protective silica fiber tiles. The black tiles on the belly, nose, and wings, where the heat would be greatest, could handle temperatures up to 1260 degrees Celsius. NASA's fleet of 5 shuttles performed 135 orbital missions over 3 decades. In addition to hosting their own experiments, the shuttles launched satellites and space telescopes, as well as delivering astronauts to space stations. During Space Shuttle Challenger's mission in February 1984, astronaut Bruce McCandless became the first human to float freely in orbit. He performed an untethered spacewalk using a specialized maneuvering unit.
The first untethered spacewalk must have been a terrifying moment. You are your own spacecraft. You are more free than almost anyone could imagine.
Well, it may have been one small step for Neil, but it's a heck of a big leap for me.